This project is all about understanding how humans and robots can work together to improve future space exploration. In this project, we don't see it as a question of humans or robots. Humans and robots work very naturally together, and they don't have to work just hand in hand. You can have robots working ahead of crew, robots working in parallel to crew or in support of crew, and robots working after crew. So there's this whole spectrum of how you can have robots really doing things to make humans more productive, more efficient, and more effective in space. A lot of things we see out there today in the world really are robots. We just don't call them robots. You pick up a cell phone, for example. Smartphones, there's a ton of software in there that makes them very intelligent. They can sense the world, they know where you are, they can provide you with information. The recent phones, you can speak to them and you can ask them questions.
What's the probability of snow?
No snow in Salt Lake City, Utah, as far as I can tell.
And that's very much the same sort of software that we're developing in our project to make robots more intelligent, to really make them useful as partners and really assistants of humans.
When astronauts perform tasks, there's a lot of setup before the task is actually started and a lot of teardown after the task is done, particularly on space stations, setting up the tools, setting up a variety of equipment. If a robot can perform that task, it allows the crew person to be much more efficient doing the things that only a crew person can do.
Yeah, so one of the interesting robots we're working with is a system called Spheres. MIT developed this about 10 years ago. They've actually had 3 of these volleyball-sized free-flying robots on station for the past 4 years. And what we're doing right now is adding an upgrade to these free flyers. They were originally made as satellites. We've added actually a smartphone, sort of a brain upgrade if you want to think of it that way, to give them cameras and onboard sensing and a Wi-Fi connection. So now we can have not just a free-flying satellite, but a free-flying robot. One of the other really exciting robots we've been working with is Robonaut 2, which was jointly developed by the NASA Johnson Space Center and General Motors. Now, Robonaut 2 is a 2-armed, dexterous humanoid robot, which means it can reach out and grab objects and manipulate them, move them around just like you and I can. It's very, very agile, very capable in what it can do in terms of the way it works with forces and being able to pick up and move things around. So we're trying to make use of Robonaut 2 to do things that humans currently have to do. Those routine, very repetitive, perhaps long duration tasks that you just need to get done. Things such as, say, filter changeout, basic maintenance. These are kinds of things that require human level dexterity, and for the very first time we have a robot that actually can do those things.
So hopefully this project will lower the workload on crew. There's a lot of tasks that they do that are very boring and dull. One is that they have to take radiological sensors and go around the station essentially measuring radiation. The other is audio dosimetry, so they have to figure out the amount of noise on station. The hope is that much like your Roomba, you can turn it on and it'll run around your house and clean your house for you, that the Sphere would eventually be able to fly around station and do some of these dull tasks for astronauts.
And there are a lot of good reasons for wanting to use robots in EVA. It is a dangerous environment. It is a place that requires the use of lots of oxygen and other things that we can't easily replace, especially on a deep space mission. So if we're able to create a robot that can do some of this work in EVA, that has huge benefits to human exploration. This project is really meant to look at how do you best use robots to improve human exploration, especially for deep space missions. And one of the things we're really trying to do is make sure that the robotic hardware, the robotic software, and the way we operate the robots is really appropriate for looking at future missions. Our tests over the next 2 years really are designed to help us understand what are all the issues associated with using robots for human spaceflight, having robots work with humans. And so I think really all of our testing is driven by our desire to create systems that really improve the way that we as humans can go out and explore the solar system.